On this graph, we have the function h of x. That means our function name is h and our input value is x. So when we look at this problem over here, h of negative 5, this means that we are inputting negative 5 into the equation, and we need to figure out what the output is. So negative 5 we need to find on the x-axis, which is here, and I can see that our function has a point right here. So my output, or my y value, is negative 2. Therefore, h of negative 5 equals negative 2. But what if we go the other way? So in this case, we have h of blank. So we are looking for the input, and we are given the output of 3. So remember, 3, that output is on the y-axis. So along this y-axis, we have here's 3. So where does this function have an output of 3? So we can see that that point occurs right here when the input was 7. Therefore, h of 7 equals 3. What does h of 3 equal? Again, the 3 being here in the parentheses means that this is an input, so we are looking for an output. So if I go to 3 on the x-axis right here, then I can see that my output would be up here at 1. So h of 3 equals 1. And again, down on this last problem, we have h of what? We're looking for the input if we are given an output of negative 5. So that means our output, or our y value, is negative 5. So we go to negative 5 on the y-axis. And if you look at this, I can see that all of these points over here have an output of negative 5, which means we have multiple inputs that give us this output. So for instance, right here, we could say h of negative 6 equals negative 5. Or right here, we could say that h of negative 7 equals negative 5. H of negative 8, h of negative 9, or even of numbers that have decimals within there. So we could say h of negative 8.2 would give us negative 5. Remember, this is still a function because it passes the vertical line test. So you can have multiple inputs that map to the same output, and that's still a function. So this is how we evaluate inputs and outputs from a graph. But what happens when we have an equation instead? So for instance, we have if m of x equals 2x plus 8. Let's look at our first two examples here. First, we want m of negative 11. That means negative 11 is your input value. We want to plug that in anywhere that we see an x in our function rule. So this would equal 2 times negative 11 plus 8. We know that 2 times negative 11 is negative 22, and negative 22 plus 8 is going to be negative 14. So m of negative 11 equals negative 14. If we go the opposite way, though, we have that m of blank equals negative 26. So negative 26 is your output, which basically means that we want to take negative 26 and set our equation equal to that, because negative 26 is your output. So m of x is negative 26, and that equals the other side of the equation, 2x plus 8. So if we were to take away 8 on both sides, negative 26 minus 8 more is negative 34, and that would equal 2x. Divide both sides by 2, and we would get that x equals negative 17. That means m of negative 17 equals negative 26. And we could check it by plugging negative 17 in here. 2 times negative 17 is negative 34, plus 8 is negative 26. It would work out. So maybe try some of these problems on your own to see how you do.